Hi dear students, how are you? I hope you will be fine in your homes. So let's start teaching. Today we will start chapter 6 of Basic Econometrics by Gujarati. Chapter 6. So basically chapter 6 is the extension of the two variable linear regression model. Already we discussed in detail in chapter 3. In this chapter basically we will discuss three topics. First one is that regression through origin. Second is units of measurement, and third is functional form. So let's discuss the regression through origin. Regression through origin. So by definition we can see that the regression line passes through the origin. We just have a rough idea and graph it how it may looks like. I just graph a positive linear function. Here we can see that x-axis origin and y-axis. So when we call regression through origin, it means regression line will pass through origin. Either it may be a negative if we were in a rectangular coordinate system, like it's positive positive or negative positive. So it may be linear function, but it may be a non-linear also. So here we can see that by definitions the regression functions that we have already discussed here, that was the intercept. We can say that the alpha, it was the beta, and usually we say that yi is equals to alpha plus beta xi plus ui. And here when we say that regression through origin, it means there is no intercept. It means alpha is equals to 0 by definition. So we can say that by definition or mathematically, regression through origin yi will be equals to just beta. We can say that it is like a beta 2 xi plus ui. So how we can illustrate this with any suitable example in the literature? Maybe you know, or you have already discussed in any other subject, or here that a well-known model in the modern portfolio theory called capital asset pricing model. Here I say that the CAPM CAPM, it means the CAPM or capital asset pricing, M stands for model. So what does the capital asset pricing model says? Basically it expresses the risk premium, how the risk premium of a security is related with the market returns, market folio returns. So we are saying that two things. One is that the risk premium, so we are saying the risk premium, and other thing is that the market portfolio return. So let's write the equation. Of capital asset pricing model, we say that the ERI, it means expected return on security I minus RJ, it means risk free rate of return. A good proxy, maybe 90-day treasury bills, is equals to beta I into ERM minus RJ. So ERM, it stands for expected rate of return on market portfolio. You maybe take any stock index. So what is this ERI minus RJ? Basically that is the risk premium, that is the risk premium, that is the function of beta coefficient times the expected market risk premium. So that is the market risk premium. So if we write these equations in statistical forms, we will just add the random error term, we call that the U. Basically, now this is the complete version of CAPM equation. What does it show? It shows that expected risk premium is equals to beta times coefficient of expected market risk premium, and usually it holds. Graphically, you can just graph it by origin. At x-axis you can write systematic risk, and y-axis you can write the security risk premium. So if we call that expected risk premium ERI minus RJ is equals to YI, if we write a complete equations, like let we incorporate the intercept alpha I plus beta I, and we represent expected market risk premium xi plus ui. So when CAPM hold, alpha I must be equals to 0, and a line must pass the origin, that is called the security market line. Security market line. And what does this slope? That is equals to beta I, and it is equals to basically vertical component, it means that is equals to ERI minus RJ over 1. So that is 1 and ERJ minus 1. So if the CAPM hold, alpha I must be equals to 0. So we just conclude these equations and how the parameter means beta, variance must be estimated. I will discuss in the second video. So wait.